All right, so video has started. So what we have, working. So we had 13 point, there was 6 as well. I don't know why I did not write. Anyway, uh 14.235 now. So we said one question from each and one question from. So this was my email. Right? So one student said go through 14.3. So in 14.3, you have double integrals in polar coordinates. So basically, you are having this polar coordinates now. So in polar coordinates, you have r theta. This is basically what it is. So remember, in polar coordinates, any point is given by r theta coordinates. So when a polar region is given, it will have curves like r is equal to f theta. R is equal to f1 theta or f2 theta. And this inside curve is r is equal to f1 theta. So in polar coordinates, your curves are not y is equal to f of x. They are r is equal to f theta. And then you are given two theta values. Theta values are straight lines. Theta is equal to alpha, theta is equal to beta. Straight lines coming from origin. Okay. So this is the region, basically, polar region is this one. Okay, this one. Between two values theta alpha, theta beta, and between two curves r is equal to f1 and f2. So when you write the when you write the variables, then dA is r dr d theta. It's not just dr d theta. This total thing is dA. Okay. Remember, dA is r dr d theta. So it means the first one is r. So you will write the limits of r first. How you write the limits of r? R is the radial line. It starts from the origin and goes outwards like this. Okay, this is my r. So just see where it starts. It starts from this inside curve and it stops at this out curve. So this blue line is basically the limits for r. So you can see here r starts from f1 theta and it goes to f2 theta. So these are the limits of r. Then you look at the limits of theta. So theta starts from this line to the outside. So theta is basically, theta is the angle, right? So if theta is the angle, it is like this, right? It starts from x-axis. It starts from x-axis and goes outwards. So this is your theta. So you have to see where theta starts. So it starts from alpha and it goes to the outer one beta. So my theta will go from alpha to beta. So these are the limits of r and theta in your polar coordinates. So let's say here they gave me this curve. Evaluate this integral over the region, this shaded region. Now you see, if I draw a line from origin, if I draw a line outside, my r starts from this line and it goes to outer one, right? So this inside curve is r is equal to 3. See, r is equal to 2, sorry. R is equal to 2 is this blue circle and outside curve is this one, cardioid. So you see my limits of r goes from 2 to 1 plus cos theta. See, r goes from 2 to 2 into 1 plus cos theta. These are the limits of r. And then inside this region, you have to decide what are your angles. So see, your angle is r is equal to theta, and you are going to this final point, which is theta is equal to 90 pi by 2. So your theta starts from Your theta starts from 0 to pi by 2. So that's how you can write the limits of polar coordinates. And then, of course, you can complete. After that, integration is
Step,
not difficult. Yes.
step. Sorry for distracting you, but the screen is not showing to me.
Why it's not showing?
You know,
I'm sharing the screen here. You can see. I can stop and again start maybe. Now, can you see it now? Can you see it now?
no, step. Wait, I will try
Hmm?
to leave and
Sorry?
rejoin.
Okay, maybe do that. Other students, can you see the screen?
Yes, doctor.
Yeah, so it means the problem was with the one person. So if she can leave and come back, I think it will work. Okay, so now if I look at, I open the assignment. In assignment 14.3, problems are 5, 7, 8, 30, 34, right? So let's see. 5, 7, 8. So let me go to book and 5, 7, 8. So 5 is not an issue because in 5, they gave me the limits. So that's not a problem, right? Here in 5 question limits are given, you just have to integrate. That's not an issue, right? First, because first is r, so cos theta is fixed. So I will only integrate r square. So this will become cos theta is fixed, so r square becomes r cubed by 3, and the limits are of r are from 0 to 1 minus sin theta d theta. So this is your first integration, and put the limits inside, then you will get cos, and you can finish it up, right? So the problem occurs when they don't give you these type of limits, like problem number 7. They said use double integral in polar coordinates to find the area of the region enclosed by the cardioid, r into 1 minus cos theta. So you see in question number 7, 14.3, they said a region enclosed by this cardioid, r into 1 minus cos theta. 1 minus cos theta. We know that the cardioid is like this. It is a heart shape. If it is plus, you have on the right side. 1 plus cos theta is on the right and 1 minus cos theta is on the left, right? So mine is 1 minus cos theta. Anyway, I think in this exam, I will give you the graph because in polar coordinates, in 10.2, we have polar coordinates, curves in polar coordinates, but we did not spend a lot of time in 1.2. So I will give you the curve, okay? I will give you the curve in polar coordinates. So they said find this area. This is r is equal to 1 minus cos theta. So you see, we only have to see what is this line. Is my cardioid starting from 0 or it is starting from some other angle? I don't know yet, right? Where it starts, what is the starting point? I don't know. So usually when your polar curve goes to the origin, your r becomes 0 here. See? So what we can do, we can put r is equal to 0 to find that point. Okay. So if I put r is equal to 0, 1 minus cos theta is 0. Cos theta is equal to 1. If cos theta is equal to 1, means theta is equal to 0. Right. So it means, yes, this is the point, not this. It means my cardioid is starting from 0. Now, if I draw any line here, right, my r starts from 0 and it goes to this curve. So these are the limits of r. So if I want to find the area of the region r, it is a double integral over dA without any function here. So I will write dA as r dr d theta. Okay, so r starts from 0 and it goes to 1 minus cos theta. These are the limits of r. Then my theta is starting from 0. We saw that this limit is 0. So it starts from 0 and it goes to 2 pi. Okay, or what you can do, you can stop here. You can start from 0 and you can stop at pi. So you can start from 0 and you can stop at pi. This give me the area of upper, this one, only this one, from 0 to pi. Then I can double it. I can multiply this by 2 to get the full area. Okay, you can do that as well. So the area that I wrote, this integral that I wrote, it only gives me the area of upper half only. So I multiplied by 2 to get the full area, upper and lower, right? To get full area. So I multiplied by 2. You can do that as well. Now I have to integrate. So let's integrate 2 from 0 to pi. Integral of r will become r square by 2. And the limits of r are from 0 to 1 minus cos theta, and d theta is still there. So now I can replace the value 2 and 2 cancels. So no need to write now, right? So 0 to pi. Now if I put 1 minus cos theta whole square, and minus 0 will give me 0. So this is what I got. I can replace this one, which gives me this, and 0 will not give me anything. So I did not put. Now I have to integrate. I cannot integrate directly. Okay, so I have to open the square. You have to open the square. 1 square is 1 minus 2 cos theta plus cos theta square. So this is the square. A square minus b square plus 2ab, right? A minus b square. So a square minus 2ab plus b square. This is what I used here. Now, I know that whenever you have cos square theta, we cannot integrate directly. So we use a formula which is called half angle formula, 1 plus cos 2 theta. So here, integral of 1 is theta from 0 to pi. Integral of cos theta is sine theta from 0 to pi. But I don't know what is the integral of cos square theta. This is the problem. Okay. This is what I don't know. So this is easy. This becomes pi minus 0. This becomes 2 times sine pi minus sine 0, right? I can put that. But here I have trouble. How to integrate this one? So whenever you have cos square theta or sine square theta, whenever you have cos square or sine square, we use this formula. These are called half angle. Only sign difference is there. See, for cos you have plus, for sine you have minus. So this is cosine. So first I will write it as 1 by 2 and 1 plus cos 2 theta. Now I can integrate this because power is gone. Power is gone. I can integrate. This becomes pi. This is 0. Sine pi 0, sine 0, 0. So this is 0. 2 into 0 plus 1 half. And now I will integrate. 1 will become theta and cos 2 theta becomes sine 2 theta. And because there is a 2 here, I divide by 2. That's it. So 0 to pi. Now I can get the answer. So I got pi here plus 1 by 2. We can replace pi for theta. So pi plus sine 2 pi by 2. And if you put 0, it will give you 0 because sine 0 is 0. Sine 2 pi is also 0. So you got just pi by 2. So pi plus pi by 2 becomes 3 pi by 2. That's your answer. So this is the area of the cardioid that is given here. So area of full cardioid is 3 pi by 2. Okay. So when we ask you the area, you have to use this formula only. This is the formula for the area. And if it is polar coordinates, I will go with r theta. If they are xy coordinates, I will go with xy.
Doctor, I want to
Okay.
ask you about the final.
What final?
You will give us the draw, or we have to draw it, the
Yeah, in
equations?
polar coordinates, I will give you the draw. But if there are other xy coordinates, if it is difficult curve, I may give you. But if it is simple curve, let's say y is equal to x, we know that simple one. Y is equal to minus x. These type of curves are very simple. Or y is equal to x square, right? So these things we know, these are easy. But in polar coordinates, of course, we did not study too many curves, cardioids and things like that. So in polar coordinates, I will promise you to give you the figure, these pictures. But for xy coordinates, I will see. If it is difficult, I will make the graph for you. But if it is simple like x or x square or square root of x, that you can do on your own. Okay. For example, square root of x is this one. Y is equal to square root of x, right? Y is equal to x square. I just made x square is this. This is y is equal to x square, right? If it is maybe log of x or exponential of x, I will give you the picture. Okay. So you should remember the simple ones. Yx square, square root of x, x minus x, like that.
Sir,
Yes.
some equations have the 1 point integers.
1 point.
The other, yeah, like the previous equation that you do.
Mm-hmm.
It's where one minus cosine to zero, I think. Then we find the other integer.
Because why we did this one, why we did this portion, to know where to start. To answer is where to start. Because you see, I know where to stop. I know the other, my coordinate is like this. So I know that this is theta is equal to pi. But I was not sure if maybe it is starting from this angle, right? Maybe my angle starts from here, from this theta. And if I don't check and I start from zero, it will give me some extra area here. That will become wrong. That's why I put r is equal to 0, just to check that whether 0 is the starting point or some other point is the starting point. So when I put r is equal to 0, the right hand side equal to 0, I got theta is equal to 0. So it means, yes, I was correct that I am starting from 0. Now this gives me the starting point, this one. But sometimes it may not be the starting point. For example, I can write the equation. For example, my equation is r is equal to 1 minus cos 2 theta, right? Or no, 1 minus cos, 1 minus 2 cos theta. Let's say this one. This also has the same shape like that. It also has this shape. But now you see, if I put r is equal to 0 and calculate this one, it gives me cos theta equal to 1 by 2. And this is 60, pi by 3, 60 degree. So it means this is not, I'm not starting from 0 now. I'm starting from pi by 3 and going towards pi. So my angle is from pi by 3 to pi, not from 0 to pi. Agree? So from here, I can see that when I'm starting my theta, theta goes from pi by 3 to pi, not from 0 to pi. So see, just by changing a simple equation, if I write 0 here, instead of pi by 3, if I write 0, it means you are starting from here. And this is the extra area you got. This was not included. This was extra, which was not included in your graph. But you started from 0, so which was your mistake? You had to start from pi by 3 because my area is only this one, this blue one, right? So if you get the blue area, you have to start from this pi by 3, not from 0. Got it? That's the reason we did this small exercise of putting r is equal to 0 and finding the theta, which will tell me where to start. Where to start. Okay?
Doctor, so now we know the we know it by the equation, yeah?
Uh-huh.
So we know it by the equation?
We know it by the equation, but how did we know? If I don't write this 2, or if I change this 2, if I write this 2 and this 3, right, your angle will change, right? So if they are both 1 1, then it was 0. When it was both 1 1, it was 0. When I write 1 2, it becomes 60 pi by 3, right? So if I change these values here, of course your initial point will change. Okay, so it's better to put r is equal to 0 before starting and see where we are starting from. But let's say if I give you a circle, r is equal to cosine theta. This is an equation of a circle, right? This is a circle which is centered at the origin. Now I don't have to put 0. Reason is that now I know that my circle is starting from theta is equal to 0 and it goes to 360. I know that I'm starting from 0 to 2 pi. Now no need to put 0. I can directly write my theta from 0 to 2 pi d theta. Now no need to put r is equal, no need of this. Got it? So it depends on your shape. Here in these two shapes, my curve is starting from origin basically. See, it is coming out of the origin. So I want to make sure that it comes out along theta is equal to 0 or along some other line. So this is what we have to be careful when the curve is coming out of the 0. So we have to see it comes out of the 0, but it what direction? Is it coming through with the angle 0 or with angle pi by 3? So I gave you two examples where in one example my curve is coming out along theta is equal to 0. But in the other example here, my r is coming out of the origin, but not along 0. It is coming along theta is equal to 60-degree angle. Okay. So this is the issue only. Got it now?
Yes.
So let's see what else we have in the assignment 8, 30, 32. So 8 is similar again. You see, this is a circle equation, right? 8, what is in 30? Okay, 30 in 30 and 32, they gave me integral in xy coordinates, but they say change it to polar coordinates. So let's see 30th problem. They gave me the 0 to 1, 0 to 1 minus y square, 0 to 1, 0 to 1 minus y square, and cosine x square plus y square dx dy, right? So I don't know. I know that this integral came from cos x square plus y square. I will write dx dy as dA over some area, right? Usually this question is given and we write it like that. Okay, but now we are coming other way around. We came back from here. So now I want to see what r is that? What r is that which give me this limit? So see, your x starts from 0. So see, x starts from 0 to x is equal to 1 minus y square. These are the limits of x, right? X starting from 0 and x goes to 1 minus y square. So look at this one. Okay, x is equal to 0 is y-axis. This is x equal to 0, right? Y-axis. But what is the other curve? Here, if I take the square, it becomes 1 minus y square. Then you can bring y square on the left. It becomes a circle of radius 1. So see, it becomes a circle of radius. So this is the other one. This other curve is this one, right? Because from here I know it's circle of radius 1, circle of radius 1. So they said your x was from 0 to this one. So these are the limits of x. X was 0 here and x was 1 minus y squared. So I made this region. Now where is y? Y is from 0 to 1. Y is from 0 to 1. It means only the first quadrant area is there because y is from 0 to 1. So y from 0 to 1, x 0. So this is the region which I wrote. This is the region in first quadrant only. No second, third quadrant is there. Now this is the region. Now because I have to convert this to polar coordinates, I will write this region in polar coordinates. Let's make this region again. This is a circle of radius 1, right? We are starting from these two angles. Okay. Now take it as a polar region R. Now you know that this polar region becomes r square equal to 1 because x square plus y square is r square, right? So I wrote this as r square equal to 1. So this becomes r equal to 1. So my equation, this circle equation is r equal to 1. So now my r starts from 0 to 1 because r starts from 0 and it goes to r is equal to 1. And theta starts from here to here. So theta starts from 0 to 90-degree angle. 90 degree is pi by 2. Okay, so these are, so now if I forget about this question, take this as a new question and write everything in polar coordinates. So you know that dA becomes r dr d theta in polar coordinates. X square plus y square becomes r square in polar coordinates, and r goes from 0 to 1. I know that from the picture now, and theta goes from 0 to pi by 2. So these two are the same integrals. They will give you the same answer. If you solve this one or this one, they will give you exactly same answer because they are both give you the same integration. This is the same integration in xy coordinates, same integration in polar coordinates. Both will give you the same answer. But we started from here. So I started from here and I wrote the general integration. From here, I wrote my region R, right? I got my polar region and I came back to this question. Okay. So when you have to change the coordinates, so from integral, get the region R, whatever that is, and from that region R, again write the integral, but now in polar coordinates. So see, we got from xy coordinates, we got the region, but now for polar coordinates like R and theta, I will get the polar coordinates. So this is the step from the integration, make the region, from the region, make the uh, integration. So now solving the integration is not a problem, right? So we can, of course, solve it with respect to r, whatever answer you get, then solve it with respect to theta and get the answer. Okay. So this is all about polar coordinates. Sometimes polar coordinates are easy. If I ask you to find use polar coordinates, I will write in the exam that use polar coordinates to solve this question. I will not ask you to decide on yourself. Okay. Anything else? Any other exercise? If not,
Yes,
then I
doctor.
can. Which one?
14.8.
So in 14 point, you see now, if you go to uh, in 14.2, let's say in 14.2, we solved double integrals in xy coordinates, right? Or I can say that in 14.2 and 14.3. In both these exercises, we did the double integration, right? Now, when a function is given, I can find this double integral. Agree? So now, if I tell you that there is something which is called lamina. Lamina is a 3D object which can be considered as 2D object. For example, a board. A board is a 3D object because it has some thickness, but because the thickness is very small, like a tabletop, if you made this table with a piece of wood, of course it will have some thickness, right? You see, it will have some thickness, but this thickness is very negligible as compared to length and the width. So we can consider this as a 2D object. So that is called a lamina, and it occupies some region, of course. If density of that region is given to you, delta xy, which is called the density, which is of course a function. This is a density function like fxy, right? And if I ask you in 14.8, and if I ask you to find the mass of this lamina, find the mass of this lamina, right? So what is mass? Mass is m, which is equal to the double integral over the region R of the density function with respect to dA. Now tell me, is there any difference between this integration or this integration? They are exactly the same. Only thing is, here I am writing function as fxy, and here I am writing function as delta xy. That's it. So basically 14.23 can gives you 14.8. There is nothing new. I will give you the formula. You don't have to worry about this formula. Similarly, there was another thing which is center of gravity, right? Center of gravity has two coordinates, x bar, y bar. So where x bar is given by 1 over mass that you calculated here, 1 over mass, and then you take the double integral of the density function multiplied with x. You see, if I multiply density function with x, I will get a new function here, right? So I will integrate that function and get x bar. And similarly, for y, I will multiply density function with y and integrate. So again, you see, it's not a new question in 14.8. It is the same double integration that we have been doing in 14.2 and 3. Okay. So these formulas will be given. If I ask you this question, I will give you the formulas. So don't worry about that. Okay. Similarly, if you have a 3D, let's say in 14.5, you had triple integral over some region G of function fx, y, z, right? This was your, sorry, dv, right? Which we, how we do it, we see that what is the, in xyz plane, we see that what is my upper surface, right, which is z is equal to, let's say, g2xy, right? Then there is a lower surface, the bottom one, lower surface, that is equal to g1xy. So see, your z is a vertical one. Z starts from the lower surface to the upper surface, right? It means if I start this question, I can write z first, z fx, y, z, whatever that function is. I can write z, which goes from lower surface g1xy to upper surface g2xy. Now, if you solve this question, this will become a function of x, y only, x and y only. That's it. No other thing. So when you have a function of x, y, you take a double integral over a. So once you are done with this inside function, you will go back to 14.2. You will go back to 14.2 because here you have a function of xy and you are integrating double integral over dA. The same thing we are doing here now. This is a function of xy only and you are taking the double integral. So we are back to 14.2 or 14.3. So in 14.5, there is just one thing which is extra, which is z, right? But dA. Now you will see what region it occupies in xy plane. So what you can do, you can write this region separately in xy plane, bring this region. So you can bring this region separately. Just write x, y now, no z, because z is gone. So whatever this region, just make that region in xy plane. Make that region in xy plane and now do it as a double integration. It's your choice now. You want to use xy coordinates or polar coordinates. If you use xy coordinates, you can go from bottom to top, y goes from this point to this point, and then x goes from extreme left to extreme right. Okay. Or if you are using polar coordinates, then you will start from origin to outwards. You write the of r and then you will decide about the thetas because we have done 2 and 3. So we know how to deal with that. So double integral, it's your choice how you handle because it is back to 14.23. Now you see in the same question, if I change this f xyz to the density function delta xyz. Let's say if I write the same triple integral over the surface G with density function xyz. Instead of f, I wrote the density function. We call it the mass of the solid. Now it is not the lamina, it is the solid G. Okay. Mass of the solid that occupies the region G. So see, the same question which is in 14.5 has become a problem in 14.8. So again, if I ask you the mass of the solid G, I will give you this formula. Okay. So that's what I wrote in my email, that the formulas from section 14.8 will be provided. Right. This is what I wrote at the end. So these formulas will be provided you. Okay. But you see this area problem, which I did at the beginning here, they said find the area of the region. You should know that this gives you the area. Always remember, when they ask you double integral to calculate the area, you see, if I integrate over R and without any function, this gives you area of R. Okay, and if I take the triple integral over the volume element without any function, it gives me the volume of G. Okay, so this gives me area of region R, and this gives me volume of solid G. Okay, so when we ask you the volume or area, then you do not put any function, and no function will be given. You see, in the question which I attempted, they did not give me any function. They said find the area of the cardioid, find the area of the region that is enclosed by the cardioid. That's it. They did not give me any inside function here. No function is needed. I am given cardioid to find the limits of integration. That's it. So only limits of integrations are needed. Okay. So these questions are not difficult. Reason is that only problem is with your formulas, and if formulas are provided, there is nothing left.
Mr. Solve another question for this for 14.8.
So here, if I go to 14.8, uh, see here, 1, 4, 14, 23. So let's say 1, see here, 1. Find the mass and center of gravity of the lamina. See, density function is given with the density bounded by x-axis, x is equal to 1 and y is equal to square root of x. So let's say 14.8 problem number 1, density function is given, delta xy is x plus y, right? And bounded by x-axis, x1 and y-x. X-axis, x is equal to 1 and y is equal to square root of x. This is the region. So see, of course, when I place this lamina somewhere, it will occupy some region. And use the here. Okay, so let's see this. Okay, so now you see x-axis is this one. This is your x-axis, right? X is equal to 1 is a vertical line. This is x equal to 1, right? And then y is equal to square root of x is like this, right? This is your y is equal to square root. So this is the region R which is occupied by the lamina. Okay. So I have to write the mass. The mass is the double integral of the density function. Simple with respect to A. So this is a question now in 14.2 basically. You see, 14.8 is done. We are done with 14.8 because I know the mass of the lamina is this. Now how to solve it? Section 14.2 will tell me how to solve, right? How to solve. So I know that when I have Cartesian coordinates, I can start from down bottom to top. Now what is this limit? This is x-axis, which is y is equal to 0, and the top curve is this one. These are the limits for y. So if I write delta xy is x plus y dy dx. Now the limits of y are from 0 to square root of x. You see, what is delta x plus y? Delta x plus y is this one. So I replace the value. Delta xy is x plus y. Now my limits of x start from 0, and to the right side this limit is 1. So my x goes from 0 to 1. Okay. So let's say this y was read from 0 to square root of x. These are the limits for y, and these are the limits for x. So that you can see where these limits are coming from. Now you just have to integrate 0 to 1. Okay, what is the integral of x with respect to y? X is constant. So constant becomes constant into y, plus y becomes y square by 2. And the limits of y are from 0 to square root of x and dx. Why I wrote y equal to 0? Because when you will put the values inside, you may replace x by 0. So it is a it can be a mistake here. So I have to be careful. I am not putting x, I am putting for y. So square root of x plus square root of x square by 2. So I put the value upper limit for y, and then the lower limit 0. 0 will give me 0. 0 plus 0, right? So nothing from 0. So I can stop here. Now I have to simplify to before integrating. X into square root of x will become x to the power 3 by 2 plus square root and square cancel, so it is x by 2. So this is my function. Now if I integrate this, it will become x 5 by 2 divided by 5 by 2 because I have to add 1, and then plus x square by 4. So this is my integration. Now I will put the values from 0 to 1. So if you put 1, it is 2 by 5 plus 1 by 4. So 2 by 5 plus 1 by 4 is 20, 13 by 20. Okay. So I think you can use calculator and see this is the mass or not. 13 by 2. I can check the answer. 14.8, question number 1. 14.8, question number 1. Mass is 13 by 20. You can see here, right? 13 by 20. And then center of gravity, right? So if I ask you the center of gravity, so center of gravity will change it a little bit. It is x bar y bar. This is a point. Center of gravity is a point. So x bar is 1 over mass into double integral of x into density function. Not just now, it is easy. Why this is easy? Because I already know the limits. Now I don't have to make this again. My limits will not change. Only change will be there will be an x here. That's it. In the formula, 1 over mass double integral. I already know the limits 0 to 1, 0 to square root of x. Only thing is I will multiply x with the density function. This is the only difference, dy dx. You see, I wrote the same integration here, same, only an x comes here and x comes here, okay, in my center of gravity. So I will not write, of course, here. So now you will multiply x inside first and then integrate, or x is constant for y. If you want to multiply x inside, it's okay. If you multiply x inside, it becomes x squared plus xy. Now you will integrate that. And mass is 1 over 13 by 20. So I can put the value 13 by 20. So this will become 20 by 13, right? 0 to 1. And now if you integrate x square, it becomes x square y and x y square by 2. Because we are integrating for y, so x square will not become x cubed by 3. Remember, x square is a constant. So if you integrate x square with y, it becomes x square into y. Because x square was a constant, it will stay there. So don't make mistake. Don't write x cubed by 3. Okay. And now you can put square root of y and 0 and then integrate with x. So I think you can complete it, right? So
Doctor,
it become, yes.
how do you put that number above m?
M is not 13 by 20. I
It's not that.
calculated that, right? So it is 13 by 20 here. So it is in the denominator. When you bring it up, it will become 20 by 13. 1 divided by 1 by 2, it is 2, right? 2 by 1. So when it goes up, if something is in the denominator a over b, actually it is b over a. Okay, this will go up, b will go up, 1 over a over b is b over a. So that's why we can write it 20 by 13. Okay, got it?
Yes.
Okay, so now you can complete this, I guess, right? X by 2 and square root of x square, and 0 will make everything 0. So now again, x square and square root of x. This is x to the power 2 plus 1 by 2 is 5 by 2, right? and here it is x squared gone, so it is x squared by 2. So now you will integrate this function. Okay, so first you should simplify and then integrate, get the answer. And for the other one, for y bar, right, for y bar, only difference is that this will become y. Okay, if it is x bar, then it is x. If it is y bar, it is y. So y bar is 1 over m double integral of y into density function dA. And because again I know the value of the limits, so they will not change. Limits will remain the same. You will not make the diagram again, but now y is multiplied by x plus y dy dx. So first you will multiply y inside, so it will become yx plus y square. And now you will integrate. So it's again 20 by 13 outside, 0 to 1 inside. And now if you integrate, x is constant, y will become y square by 2, right? And y square will become y cubed by 3 from 0 to square root of x dx. And now you will put x and then 0, see what you get, answer and complete it. Okay. So these two integrations are now, of course, easy. You can do it. And the answer you can match at the end. Your answer should be this 190 by 273 and 6 by 30. So this answer should be 190 by 273 and this should be 6 by 30. So just check it. Okay. Confirm if they are. So see, in 14.8, there is nothing new. The same integrations that you did in 14.2, 3, and 5, the same integrations, only the new formula is there. But formula, you should not worry because I will provide you the formulas. That's it. So in the formula, you only have to put the density function and then write the limits. But limits also only for the first time. Only for the first time you have to struggle how to write limits from this figure. But after that, when you write x bar, y bar formulas, no need to worry about that. Limits will not change. Exact same limits will carry down here in the formulas. Okay. Anything in chapter 13? So it's pretty much it in chapter 14. So in chapter 13, let me just recall in 13.7, actually in 13.6, you studied a gradient of a function, gradient of f. If you have fx, y, z, then what is the gradient? Gradient is written as del of f. Del of f is fx, fy, fz. You find three partial derivatives and write them as a vector. This is a vector gradient of f. But then there, from the gradient, we found the directional derivative of a function. That was gradient of f into the vector u, right? This was. But as I think in the email I mentioned that I will give you problem from 13.7. But in 13.7, you also need gradient of f. So basically, when a surface is given f x y z is equal to 0, this is the equation of a surface. If your surface is given z is equal to fxy, what you can do, you can bring z on the other side. You can write fxy minus z equal to 0 and call this whole thing as fxyz. You can do that, okay? So you write surface like that. When you write surface like that, then at any point you have to find the equation of tangent plane, right? This is the tangent plane to the surface. This is the surface. Right? So this is a given. Surface is given to you. And a point is also given. X naught, Y naught, Z naught. The point is also given. You have to find the equation of tangent plane. Equation of tangent plane has the formula fx as x minus x naught plus fy, because this gives you the normal vector. Let me explain. For equation of tangent plane, I need a point and a normal vector. A normal vector. Normal vector comes from the gradient, which you found this gradient. This is the normal vector, right? Fx, fy, fz. That's why we calculate this gradient. And we know that if the gradient normal vector has your, if the normal vector has the components a, b, c, we have this equation of plane. A into x minus x naught, y into y minus y naught, c into z minus z naught equal to 0. This is the equation of tangent plane. But now my normal vector a, b, c is given by fx, fy, fz. So I just replace this by fx, fy, fz. Okay, where fx, fy, fz are calculated at a point. Always remember, these are not the variable. These are calculated at point P, x naught, y naught, z. Okay. And if I ask you what is the equation of the normal line here, then equation of normal line, which are parametric equations of normal line are x is equal to x naught plus at. You remember this from chapter 11, y naught plus bt, z is equal to z naught plus ct. But now we know that a, b, c are fx, fy, fz. So we can just put fx, fy, fz here. So these are very simple question 13.7. Okay, and the value of t is r. T goes to r. Okay, so this is if any surface is given, and at any point you want to find what is the equation of the normal line. This is the equation of normal line. Okay, normal line. Because you know that normal line has the same direction vector as n. That's why I used the components of n, fx, fy, fz. Very simple questions from chapter 13.7. So of course, x
Mister,
naught, y naught. Yes.
Mister, can you solve question 2 from the assignment and lesson 13.7? I tried to solve it like you teach us, but Mister, on this question there is z a variable in every term.
Let me solve. Where is 13 point?
Also, when we use the normal equation that with cosine n, how could we find n2?
13.7 here. So question number, which question you are saying?
Number 2.
13.7 to 412. This one.
Yes,
So see the surface is given x z. So the left side of the surface, this is your f. This is your capital F. Okay. And this is the point 2 minus 1 1. So let me write x z minus y z cube. Question number 2, 13.7. X z minus y z cube plus yz square equal to 2. On the right side, if it is a constant on the right, then it's okay. No need to bring it to the left. You can just call this fxyz. Okay, the left hand side, which is xz minus yz cube plus yz square. Okay, this is my fx. And then what is the point that is given to me? They gave me the point minus 2 1 1, right? Minus 2 minus 1, no, 2 minus 1 1. 2 minus 1 1. So 2 minus 1. Okay. So now what I need, first of all, I need fx. Fx is partial f by partial x, right? Derivative with respect to x. So x will become 1. So you got z. This is 0. This is 0. Just that. Fy is the partial derivative with respect to y. So what is that? 0 minus 1 z cube. So minus z cube plus z square. Right? And now what is the third one? Partial fz. Fz, which is partial f by partial z. That will be x into z1 minus 3yz square plus 2yz, because z is everywhere now, z. So I got three terms. Now you will calculate these things at the point. This is what I was mentioning at the top, that these fx, fy, fz are calculated at a point. So I will replace the point to 1 minus 1, 1. Okay, at this point. So my fx, you can also write it as a. My a fx becomes z. Z is 1. B is fy, which is minus 1 cube plus 1 square. So that is 0, right? And then fz, which is my c, which is x is 2, y is minus 1, z is 1.
Mister, we cannot make 3z to the power 2
Where?
when we taking fx and fy and fz.
Where is the
Fx,
power?
I mean, look at fy. There is negative z3. We can make
Yeah,
it
so
3 negative 3z to the power 2 plus 2z.
z is 1. Z is 1. So 1 cube is 1. Minus 1 cube is 1 and 1 square is also 1. So it is 0.
No,
Okay.
I mean, okay.
Minus is outside. Minus is not in. Here minus is inside. You see, y is minus 1. So I put it here. 2 into y minus 1 and z1. Now it will become minus minus plus 3. And this is minus 2. So the answer is 3 here. Okay. Here minus was outside. Z was 1. So minus 1 cube is minus 1 plus 1. So now you can write the equation of tangent plane. So equation of tangent plane is a into x minus x naught plus b into y minus y naught plus c into z minus z naught equal to. Got it? So now it is x minus 2. This becomes 0 plus 3z minus 3 equal to 0. So you can write x plus 3z equal to 5. Because minus 2 minus 3 is 5. Minus 5, it will become 5. So this is the required equation of tangent plane. X plus 3z equal to 5. Fine. Is that find the parametric equation of the normal line? Same point, same. Now I don't need to calculate anything again. Now I can directly write the parametric equations of normal line. So what are those? Are x is equal to x naught, which is 2, y is equal to y naught, which is 1, and z is equal to z naught, which is 1, plus at, a is 1, right? Plus bt, which is 0t, plus ct, which is 3t. That's it. T belongs to R. Just one step answer. These are the parametric equation of line. Because I have ABC 103, so I wrote 103 here, and x naught, y naught, z naught. I just replaced the values, got the equations of normal line. Okay. Is that fine? So these are also similar. 2, 7, 2, 4 and 12. So see, in 4 is fine, but in 12, you see 12 is z is equal to x squared plus y squared. So this is what I was saying. Here your fxy will not be just the right hand side. It will not be just x1 by 2 plus y1 by 2. Here I need to bring z on the other side. If it is a constant on the right side, no need to bring it on the left. You can just call the left side as f. If you bring constant on the right, it is fine. Answer will not change. But you cannot leave z on the left. If there is any x, y, z on the right in all these questions, you can bring z on the left. So you see, your derivative with respect to z will always be minus 1. Okay, and these two derivatives, fx will be 1 over 2 square root of x, fy will be 1 over 2 square root of y, and fz will be -1. So these are your three things, and then you can just start like that. You got fx, fy, fz. Now at the point, whatever point is given, put the values and get fx, fy, fz. That's your answer. Okay, and the last thing is the finding maxima minima of function of two variables. So if I see in 13.8, 10, 16, 32. So let me do 10th. Okay, 10, problem number 10. X squared plus xy minus 2y. Fxy is given x squared plus xy minus 2y. X squared plus xy minus 2y minus 2x plus 1. Right? Either we can ask find all relative maxima minima saddle points, or we can say that first thing is find critical points, because I know that all the relative maxima minima saddle points, they occur at critical points. So this is your step one. Critical points is the first thing. What are the critical points? Critical points are those where fx and fy both are 0. So basically I need these things. So I will calculate fx. The derivative with respect to x is 2x plus 1y minus 2. And fy is 0 plus y. No, with respect to y, it is x from here, a minus 2 from here. That's it, right? X minus 2. Now I will set both these equal to 0 to put fx equal to 0, fy equal to 0. So what does that mean? Fx equal to 0 means 2x plus y equal to 0 minus 2. Minus 2 will go there, it will become 0, or let me write minus 2 equal to 0, and the second is x minus 2 equal to 0. You can call this 1, you can call this 2. Now you see from this 2, from 2 my x is 2, right? If I bring 2, I got the value of x. Put this in 1, put it in 1, put this in 1. If I put x is equal to 2 in 1, it will become 2 into 2 plus y minus 2 equal to 0. So 4 plus y minus 2 equal to 0. So y becomes minus 2. This is the value of y. Okay. So therefore, the only critical point is I got only one critical point. So therefore, the only critical point is 2, 2. X is 2, x is 2, y minus 2. X2, y minus 2. You can put it back here. You will see 0. If you put x2 here, it's 4 minus 2 minus 2, 0. If you put x2 here, 2 minus 2, 0. So see, both equations are satisfied. Now, you got a critical point. Now, step 2 is check whether, right, whether it's a maxima, minima, what, right? So we can also call it classify critical point, classify the critical point as relative maxima, relative minima, or saddle, whatever, right? It may not be anything, whatever that is. This is called the classification of a critical point. What we do, for that we calculate second derivatives, fxx, right, which is fx with x will give me only 2 plus 0 minus 0, just 2. Then fxy, fx with y gives you only 1, and then fyy, which gives me 0. There is no y here, so it is 0. Then you put the point here at the point minus 2, at the critical point, but they will not change. In this case, they will not change, but you have to put the point 2 and minus 2 in here, but they remain the same. Fx remains 2 because they are constants, so they will not change. If there is any x, y, z here, of course, you will put the point and calculate these things. Now, step 3 is calculate d. D is fxx, fyy minus fxy whole square, fxy whole square. So you put the value fxx is 2, fyy is 1, and fxy is 0. So you got 2. If it is positive, then go ahead. Note here, if d is negative, stop. Say that f has saddle point. Okay, f has saddle point at critical point minus 2, 2. If d is negative, don't go ahead. Stop and say it is a saddle point. But my d is positive. If d is positive, then don't stop. Go ahead. Right? Don't stop and check the sign of fxx. Check the sign of fxx. Fxx is 2. It is positive. Right? Fxx is 2. If it is positive, you have a relative minimum. F has relative minima at x is equal to 2. At critical point, sorry, relative minima at 2 minus 2. Okay, and that's it. Now we cannot do any other thing. If there is any other critical point, then we will check that as well. Okay, but we had only one critical point, it becomes a minima. It means there is no saddle point, no maximum value. So we only have one relative minima. If again, I'm writing this note for you. If d is positive and fxx is negative, then f has relative maximum. Okay, so see, for both maximum and minimum, d is always positive. Remember, d is always positive for both. So fxx will tell you if xx is positive, it gives you minima. If xxx is negative, it gives you maxima. So that's how you check the relative maxima and minima. Okay, guys, I think this now completes everything. We have
Mister, I have a question for your
yes,
end. Mister, in the assignment, you give us example 32.
32
There, yeah, in this exam, in this lesson,
here.
yeah, but 31 is there is an example in the chapter and the lesson, same 31. Do you will bring 31
No, 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 I will not give you. I will give you from these beginning questions only. Okay.
from 10 and 9?
Yeah, the 9 to 20, whatever questions were that. 10 and 16 I gave you, right? So
So,
anything I can pick from here. So only this now. Do
so
only
Mister,
this.
you will
Don't
not bring with sine and cosine?
sine, cosine, chances are less. So okay, so if you try 10 and 16, they are enough practice. If you want something else, maybe try 11 if you want. This looks like that, right? 11,
Okay,
12, they are easier. 9, 11, 12, they are easier functions. So maybe these are enough. Okay.
okay,
Even if you do 10 and 16, I think they will be enough practice. But if you have time, if you are done with 10 and 16 and you have time, I think you can try 9, 11, 12, any one of them. Okay. So no 31, 32, they are about absolute maximum, minimum, right? So just drop that, skip it. Okay. So just do the initial problems from 9 to 16. Okay. Anything else?
Mister, how it's the marks will be each
I
question?
think mostly they are the same. There are five questions, so maybe eight marks for every question, or maybe if I see if there are more parts for any problem, I may give you more. But usually all are almost the same. I think um, yeah. So you can in mind you can almost 8 marks each, I think. But if maybe if someone has 7 marks, the other one may have 9 marks like that, but it will not be very different. Okay, so in all these sections, they almost contain similar same weightage. Okay.
Mr. 14.5 and 14.8 will bring one question related to that equation.
14.5 and 8, one question only.
Yeah,
So
it's
I
that
may give
equation.
you, let's say I may give you one, if I go back here, I may give you one simple triple integration with the limits, right? I may give you one question where limits are written like that, right? And I ask you to evaluate this. So then you don't have to make any picture, nothing. You can just start and solve the integration. And I may give you one with density function and with the region R where you have to write the limits. But remember, if the limits are if the limits if the region is a box only, if it is a box type thing, no curves there, then the limits are always constant. Then you have to just see where x goes from. Your x may go from a to b, y may go from just c to d, and z may go from k to l, right? Then these limits are very easy. If these are constant limits, you can start with anything. You can write z, which is going from k to l. Then you can write y, which goes from c to d. Then you can write x, which goes from a to b. So for a box, rectangular box, the limits are very easy. Okay, your x goes from a, b, c, d. So this is very easy. So maybe you have a box. So you have to be very careful that what is this solid G. If solid G is just a box, your limits will all be constants and they will become very easy. Question will become very easy, right? But if it is not a box, like here I gave you one example where you have to change it to double integral by writing the z limits first. So you have to be careful what is your region in 14.8 or 14.5. Okay. But in 14.8, formulas will be given to you. So you just have to concentrate on the region, on the limits of the integration. And that also you write only once, not many times. Okay, that hopefully that helps. Okay. So I will save this file and upload on Moodle, and I will also upload the link on the Moodle for the video so you can watch later as well. In the evening, in the night, whenever you need, you can go to the typical question and redo that. All right, guys. So I can stop now.
Yes, thank you, Mr.
All right. So recording, this recording will be saved. Okay.